Good afternoon, everyone. I'm going to show you today machine learning project. How you have to do a project if you get a specific task. So how the process will be to do to get output to perform a task. How we will do. I will explain everything today. So I'm gonna show you the machine learning topic. I've taken the some projects. It's not as a project. It's like a small task, and whatever it may be, you can take it as a project or task. Whatever it doesn't mean that. So I have taken here machine learning by using Python. I'm doing the project here. By using Python, I'm doing machine learning project here. So what the project I'm going to do? First, in machine learning, there is a process to perform specific task to get the output. What's the process? Like first we have to take the data. So the particular data we have to give the algorithm, machine learning algorithm. Then only we'll get the output. I think you have understood. I'll repeat it once again. We'll take one input data. Data as input we will take in machine learning. So we'll take the data as input. So the data input data we will give to the machine learning algorithm. When we apply the data to the machine learning algorithm, then only we will get the output here. So that is the actual process. If you want to perform any task in machine learning by using Python, whatever it by not by using Python, whatever the software you are using, this is the actual process in machine learning to perform a specific task here. So I have taken some data. I've already, as I told you that, sorry, I have taken the data. I have registered the data, age and speed of 15 bytes as they were passing a railway gate. I think you have understood this. I have taken the data of age line by we have to take the data in Excel sheet actually. In Excel sheet we have to type age as well as speed like age 10 age 20 age 30 age 40 age 50 age like that we have to create a data and that we have to take the two cells in the excel sheet age one cell and the speed is another cell. In that cell we have to enter the speed. So after saving the file, the particular excel file, after you will save after created the data. So the data is ready to give to the algorithm. As I told you previously, the data only we will give input to the machine learning algorithm. So we have taken the data already. We have entered age as well as speed. That is what we want in this project. So actually I'm gonna tell you the title of the project is when the person, when the age of the person passing a railway gate, how much speed, how how the candidate age, how he is old, for how much old he can maintain the speed to pass a railway gate. So that is what the actual heading, I mean title here. So we have taken the data age and speed and we have saved the file of excel sheet and it has become like PDF or whatever the Excel it is in the form of the document is in the form of Excel sheet. Then we can find the data in that because we have already entered that according to our requirements. So here we have taken data. So how will execute the data? How we will import the data and how we will execute the program and how will do the task successfully to get output. So I will show you everything here. So Anaconda Navigator, there is a software. I can say that as a software, good software to use because in Anaconda there are many tools we can use. Yeah, there are many modules which is comes under Python modules like a cmd.exe prompt, Jupyter Lab, Jupyter Notepad, PowerShells, and so Blue Visual is mostly used to visualization, graphical visualization. We use this graph visualization. Sorry. So Orange 3. There are many tools and many modules are there which is related to the Python. So why I'm telling you this is the best software to use to execute the Python programs. Why I'm telling is this is the best one because we can see multiple tools here itself in the same interface. We can use it, we can launch it and we can use it. But if you want to do from a web, you have to install separately, like cmd xprompt you have to install separately, jupyter lab you have to install separately, and jupyter notebook as well you install separately. So if you want to do any project or any task, we can use this as there are a lot of benefits are there in Anukunda Navigator. So that's why I'm using here. So I think you have understood. So why I've chosen Anaconda Navigator? You can easily perform any task here by launching a modules directly here itself. So I have launched Jupyter Notebook. Why I've launched Jupyter Notebook is nothing but we can write the Python program here. So sorry, I will show you from the starting point here. when we open when we open Jupyter Notebook, when we launch this, we will redirect to this page directly. So here here there is the option new, there is a Python 3. We can when we click on this, the page will be redirected to this page. So we can able to perform many of the tasks which comes under which are related to Python. We can execute any of the problem, we can execute any of the project, whatever the we are required, we have requirement, we can do here itself in this Jupyter Notebook. Like you can see here, this is a Python 3. So if you want to do the Python 3, you have to install several modules, several tools, several libraries in Python. If you use the Anaconda Navigator, when we click on Jupyter, it will be directly opened to write. So it is a flexible to write the programming code by using Anaconda Navigator. We can see multiple of the tools and multiple of the libraries in the same page itself. So that is why I'm telling you all these things. So that's your choice of what the tool, what the library you want to use, what you want to install in your separate system. So I have already told you, as I told you to people, that when we are doing a specific task, when we are performing specific task, what I've told you in machine learning, first we will take data as input, and then the data will be applied to the machine learning algorithm, then only we'll get the output. So how do we have to import the data? So we have taken here, we can here uh, edit everything. But we can't write like Excel sheet, no, like a speed age this much, speed this much. We can write somewhat like 10 values, 15 values, and 20 values. At last, at 10 values we can write. But if the data has more, how can you write? You can't write. So that's why you have to take the separate Excel sheet and you have to uh, enter the data, what are the requirements, what are the data you want, what are the expected value you want. You can enter the separately in the Excel sheet, then only the Excel sheet directly imported to this page. Yeah, this page we have to import the file. To import, what we have to do? First, already we have saved Excel data which we have taken age and speed. So there is an option, you can see that upload. Click on upload, then you will be directly redirected to the your system browser. So you can select their Excel file which we have already stored data and data like age and speed values. So we can select the document like this, like we can see that here, entitled untitled .ipynb. So like this you will be having Excel sheet, so you have to open it directly. Like I have selected this, actually there is no data, I just showing I'm just showing a sample. So I've opened here. If you click on upload, the Excel sheet will be uploaded to the Jupyter Notebook. Okay, I think you have understood. The Excel sheet directly uploaded to the Jupyter Notebook. Then only after uploading then only if you click dot csv, actually I don't know the tag what the in python what the tag to import, I don't know what the tag is there to import the data in the Jupyter notebook, I don't know actually, but I know this dot csv is there, something tag will be there. When we type this import dot csv, directly the excel data which we have uploaded in the Jupyter notebook, that will be stored directly uh, into this programming, like into this page it will be directly come, we can get is directly only when we upload the data. I've already told you, just we have to upload the data in the Jupyter notebook itself, then only we can perform as here directly the data excel data will we can get excel data from here directly, like there will be some notation like .csv or something else will be there, so directly the data will be imported to this page and then we can easily get the output. So that is what I'm telling you. I think you people have understood about this tutorial. So now I don't want to upload any of the file, I don't want to take any data like excel data, I can directly give the data in the same page itself. I will show you how to do. As I already told you, if it is 10 values, 15 values, it is okay to do. But there are plenty of values. How do you do? What will you do? You will go to Excel and you will type enter the data, and then only after the entering the data, you will save the file, and you will come to here. You will click on the option upload. Then only you will upload the file in the Jupyter notebook. Jupyter notebook. Some tag will be there. .csv something tag will be there. You can get the data to here easily. So this is the process. If we have the data, if we have the large type of data, but I'm taking here just 15. I have told you already. I just told you I have registered the data age and speed of 15 bytes only. So I can take the values here itself. I don't want to upload, I don't want to go for Excel and don't want to type all the data, and I can directly upload and I can directly text from here itself in the page. So I will show you how to do that is. So I think you have understood. So I will start the program and I will show what will happen. You know, here I have told you that when we have to take the data as input and we will give to the machine learning algorithm, then only we will get the output. As saying that what the machine learning algorithm you have to take, that's what we have to know. Here in the machine learning, when we give input as numerical, the same when we will get the numerical as output, we use linear regression method here. Linear regression algorithm we use in the machine learning. When we will give the input as a numerical, when we will get the output as a numerical, we will consider, we have to take the algorithm as linear regression algorithm in the machine learning. So we are giving here the age will be in numerical form, like 10, 20, 30, 40, 50, which is in numerical form, and the speed also which is in the form of numerical, like 20 kilometer per hour, 30 kilometer per hour, 40, 50 kilometer per hour. That's why we are using here linear regression algorithm. So we have taken data 15 bytes age we have taken. So next, what's next? That is algorithm we have to choose. We have chosen algorithm, that is linear regression algorithm we have chosen, that is machine learning algorithm. Why we have chosen linear regression? Because the input and output is here or in the both in the numerical state. That's why we have taken only linear regression here. So we will get the output. So that is what the actual process here. So I will directly enter the data here itself. I don't want to go for Excel datasets because I just have some small task, like only 15 labels are there. So only 15 test cases I have to perform. So that's why I directly enter the data here itself, and we can directly see the output here itself. So I will show you. So here a machine learning, actually it's a statistics related algorithm, or statistical related operations will be performed in machine learning. Like whatever the task you will take, you have to you have to show you have to show the output which is in the form of statistics and a graphical representation itself. Like you will be having x-axis as well as y-axis. According to the x and y variables only, we can draw the graph. We can observe that according to x-axis and y-axis only we can draw the graph and all. So the output we will show here. We are predicting what we are predicting here. If the person, if the person, for example, if we take the age old of the person is 10, the age of the person is 10, uh, to pass the railway gate, to pass the railway gate, how he maintains the speed, like either 20 kilometer per hour, 30 kilometer per hour, 40 kilometer. How much he maintains the speed while passing a railway gate according to the age of the person. So that is what we have to here predicting the speed of the person, how much he can maintain the speed while passing a railway gate. The 10-year-old man, and 20-year-old man, 30-year-old man. So how much he is maintaining the speed. So we are predicting speed here. So prediction is the most important thing in the machine learning. Actually, it is only for prediction. Machine learning, if we talk much about that, I can say that the prediction is the only one task. We keep on performing. We keep performing only specific task on prediction itself in the machine learning. So that is what actually we are going to do here. First, I will take two variables like A and B values. Like as I told you, x-axis and y-axis will be there to show the graphical representation. To visualize the graph, we need x and y axis as well as variable values. Like I will clearly explain here. Here, x-axis taken as A. Okay, the x-axis in the graphical representation, the x-axis taken as A, and the y-axis taken as B. Okay, the y-axis taken as B. Hmm. A x A axis represent age. I mean x axis represents age. Okay, and B axis represent the speed. Okay, B axis represents. I have registered the age and speed of 15 bikes as they were crossing a railway gate. I have already told you the graphical representation is x-axis and as well as y-axis. So x-axis I taken as a variable and y-axis I have taken as b variable. So so here we can see that a is the variable, b is the variable. So a is age, b is speed. So age will be in x-axis, speed values will be in y-axis. So according to these values only, the we can draw the graph. So according to the age and speed values only, we can draw the graph. So I will show you how it will be performed. So I've already told you when you are performing any specific task by using Python, you can execute, you can write, you can if you want to do the project, if you want to do the task, and whatever you want to do by using programming by using Python, you can use the Jupyter notebook I have told you. Then we can write here the program. What I've told you the task about the 15 bytes speed and age while passing the railway gate. So we will directly execute it here itself. We don't need any Excel sheet and all, because we are just taking the 15 trials itself. So we can directly enter the data here itself. We don't want to take any Excel sheet and we need to type. Like if there is any much data, we have to go to the Excel sheet and we have to type the enter the data. Then only we have to save it. We have to import in this page only. Then only we will get the output particular. So here we no need to take any Excel sheet data, because here we have just less data, just a small data. We have just 15 cases, just 15 trials are there to perform. So that's why I'm taking directly here itself the data. I don't want to take any Excel data sheet data as input here. So I will show you how to visualize and how to sketch, how to draw the uh, I've told you that the graphical representation is only about machine learning statistics. Machine learning only related to the statistics. That's why we only visualize the outputs in graphical representation itself. So how to create the x-axis and y-axis with the data values, I will show you now here. Actually, as I told you, let's draw scatter plot according to the given data of variables. Okay, yeah, let's start. Import. Plot. Sorry, actually, I've forgot that mentioned, so that's why I'm doing a error here. So sorry for the late. Just adjusting that. Pie plot as PLT. We are taking pie plot as PLT. Here, matplotlib.pyplot. What is this? If you ask the question, I can say that we used this to draw the graph. I told you, I already told you that we need to we need to visualize the graphical representation here. Okay, that's why we are using here matplotlib.pyplot as PLT. We are taking the whole as PLT. Yeah, that's what I'm trying to explain you. So here, I've already told you that we are gonna taking a data here, like directly data, taking data like age. I've already told you that x-axis as a variable, y-axis as b variable. So a is age, b is speed. So 6, 8, 9, 8, 3, 18, 3, 11, 16, 12, 5, 10, 7, 20, 30. We have taken age values: 6-year-old, 8-year-old, 9-year-old, 8-year-old, 3-year-old, 18, 3, 11, whatever. And we are taking now speed values. And speed values is taken in the variable b. 102 speed, 103 speed, 301 speed, 67 speed, 69 speed, 72 speed, 74 speed, 76 speed, 86 speed, 87 speed, 86 speed, 88 speed, 94 speed, 85 speed, and 78. So this is the data which we wanted to give here. A has taken us age and B has taken us speed. Okay, let's uh, let's draw scatter plot here and plot, sorry, plt dot scatter of A comma B. Here plt dot show. Here we can run the instructions. Yeah, we have got. Here you can see, as I already told you that I have given A values as age, B values as speed. So A as x-axis and B as y-axis. So A value already dotted, b value also already dotted. So how it will perform like this? So we have taken the data, we have taken the graphical representation. So we have seen how uh, how the data is locating in the graphical representation. So what we will do now? Next step, we need to fit the straight line to the data to predict the values in the machine learning. We have to fit a straight line for the specific data. What we have the given data, we need to fit the straight line for the particular data. So to fit the straight line, we import scipy. Scipy is like a model. I've already told you there are many libraries in the Python. So scipy is also one of the library which will give which will use the array of numbers. We have, suppose for example, we have array. So on arrays it will perform quickly, like effectively performance will be there in the scipy library. So scipy is a model in linear regression. So by using scipy only we can fit the line, because we have taken the array values ikkada. If we take, if we look into this, the a is in the form of array. There are plenty of the elements are there, and here also we can see the speed. There are plenty of the numbers are there. So like that, uh, to perform array effectively, we use the library scipy in the machine learning. So to fit the straight line, here we are going to fit the straight line for the specific data. So how we are going to fit the straight line? I will show you. Import mat plot leg dot pyplot as plt. I told you that from scipy import stats. Here scipy import stats. Stats is nothing but statistic. So what the data we have given, we have to take here. What the data is 6, 8, 9, 8, 3, 18, 3, 11, 16, 12, 5, 10, 7, 20, 13. Is everything okay there? The data is same now. 6 side 9, 8, 3, 18, 3, 11, 3, 18, 3, 11, 16, 12, 5, 10, 16, 12, 5, 10, 7, 20, 13. So next is the age. Next speed we have to take. Right, cover the values, speed values 102, 103, 111, 67, 69, 72, 74, 76, 86, 87, 86, 86, 87, 86, and 88, 94, 85, 78. So the data, okay, done the data. So as I told you, to fit the straight line, the straight line is a predicted value. The most important thing is the straight line, fitting the straight line is important in linear regression. By the straight line only we can predict the value. That is the most important thing. So we need to fit the straight line clearly. So here slope intercept r comma p comma std er r is equal to stats stats dot regress a comma b def my func a return return slope into mm, a plus intercept and my model is equal to list of map of my funcano a plot dot scatter a comma b plot dot show. So this is the program to write to fit the straight line for the given data in a linear regression. So now let's run the program. How we'll get the straight line for the particular data. So let's run. So we have got some errors here. Function plot is not defined. Plot as plot. Actually, I forgot the thing to right here. PLT. Actually, it's wrong. We have already taken pyplot as a PLT. We have written here plot dot PLOT. I think a comma model will come a comma my model. Do here PLT dot show and we can run in our here. Yeah, we have got here the straight line without any errors. We have got here. I've already told you to we have to fit the straight line. Yeah, this is the straight line. The according to the given data according to the data, the straight line has fitted like this. Yeah, this is the data fitting. So here, how do we know? Either it will give the data will give good accuracy. I mean, good output or not. We have to know by calculating r squared value. Here, there will be a r squared value. By using r squared value method, we can know the relationship between the x-axis and y-axis. I mean a variables and b variables, whether it's suitable or not. So I'm telling you, just keep it in mind. So the relationship between x-axis and y-axis, if there is no relationship between x-axis and y-axis, linear regression algorithm cannot be used to predict anything. So when you got the relationship between those x-axis and y-axis only, it will be performed like a linear regression. Can be predicted any value, whether there is no relation between the x-axis and y-axis, and you cannot able to predict the value by using linear regression in machine learning. That is what I'm going to tell you. Please understand that. So R squared value ranges from -1 to +1. If you get, we will do that calculation by using Python. So if you get the value -1 to the ranges, R squared value range in between -1 to +1. If you perform the, if you calculate the value which is not which is not get between -1 to +1, so it is not it will not show any accuracy, it will not show any perfect output. So if you get only -1 to +1 while calculating the R value by using the given variables, then only you will get the specific and the accuracy, good output from the given data. Otherwise, you can't able to get. So now see how the R squared value will give for the particular data. So now we'll see whether it will give accuracy or not. So how to calculate the R squared value? So I will show you. Here again we are using SciPy using import statisticals here, import stats, and according to the data we are taking here, it's 6 8 I think, yeah, 6 8 9 8 6 8 9 6 8 9 8 6 9 8 8 3 18 3 11 16 12 5 10 7 20 13. So we have taken each. Now we are looking for speed. Now we are entering the speed values. Let's observe 102, 103, 111, sorry, comma, 111, 67, 69, 72, 74, 76, 86, 87, 86, 88, 94, 85, 78. This is the data, already we know that. So we are calculating the R value here to know the to know whether it will give the good accuracy or not. So slope here we have to write slope intercept. Actually my speed level is low because uh, I actually have written code in a notebook, and while it is not appearing clearly, so that's why it's getting late to type. Air equal to stats dot l n r e g r e double s a comma b. Yeah, print r. R is nothing but r value. here did print. Yeah, let's run the code. We have got here minus 0.064. What I've told you, the r square, the r squared value should be in between -1 to +1. Then only we will get the accuracy. Then only this is the good algorithm. Then only the linear regression is good. I mean, linear algorithm is suitable for the given data. Then only we will come to know, according to the r squared value only, we will come to know that the linear regression is a suitable algorithm for the given data. If it is not showing like that, we need to change either data or algorithm according to our requirement. We can change either data. We need to text up some more data, or we need to change this modifications in the data, or otherwise we need to change the algorithm. Like there are many algorithms in machine learning, like linear regression. We have taken already. Logistic regression is there. So like that, we will change either algorithm or the data. So we will do after testing the value. After testing the R-squared value, we came to know that it is not accuracy. Still, we will do the output. How we will get the output? How the value will get the output? We will see here. So I am texting here. Now I want to predict the age of 20-year-old. How much speed he maintains to continue? I mean to cross the railway gate. To cross the railway gate, how much the 20-year boy maintains? How much speed he maintains? So let's see here from Skyfi board stats is equal to 6, 8, 9, 8, 3, 18, 3, 11, 16, 12, 5, 10, 7, 20, 30. So we'll take now speed values. 102, 103, 111, 67, 69, 72, 74, 76, 86, 87, 86, 88, 94, 85, 78. So we have taken speed values. Uh, let's see the output or the prediction output. Let's see here. We have taken the values and slow, intercept, and or comma b, standard error is equal to error is equal to st ats dot linear regression regress of a comma b. So start linear regress, lin regress. Okay, A and B here we have taken. So now def func my function here. My func of a return slow into a plus intercept slope into a plus intercept. Now we are going to find the speed. We are going to predict the speed here. Speed is equal to my func of what the old of the person, 20-year-old boy. I have given that I want to predict the age of 20-year-old man. How much speed he wants to maintain while crossing the railway gate. So I want 20-year-old boy. So I am typing here as 20. Okay, speed. So print the speed. I need to print the speed. That's what our output. That's why we need to print the speed. So let's run the program. How the speed he maintains while crossing the railway gate. Let's run it. 83.5. While crossing the railway gate, while crossing the railway, 20-year-old man will maintain the speed 83.54, the speed a kilometer per hour he maintains. So this is the project. This is about the project. We have got the output. So this is the output about our project. So I am kindly making a request that if there is any mistake, so please excuse me. So thank you very much, and thank you.